Hi guys, yeah, welcome back to my channel. Today we want to quickly look at questions which are likely to come out in your JAMB examination. Likely questions from JAMB. The first one thing you should know as a JAMBite out there, I want to get this clear to you. If you are given a question, learn to understand the question first, then the topics. Because if you are to pass JAMB successively, any question given to you as a JAMBite, you should be able to tell the topic at which that questions fall under. Look at this kind of a question now. We can easily relate it that we are talking about electronic configuration, but not only electronic configuration, but unpaired electron. And as a JAMBite, if someone should ask you that, what is unpaired electron? They are those electrons that make an element stable. So for example now, the electronic configuration of an element is 1s2, 2s2, 2p6, 3s2 and 3p3. For those of you that are having issues with how to write the electronic configuration, I've deposited a video on electronic configuration which I state the Ohm's rule, the above principle. So now, how many unpaired electrons are there in the elements? So first and foremost, the first thing I'm going to do is that learn to identify the elements. So we have this. Now we can say we have this and we have what's this one is what we have into 2 plus 6 we have 8, 2 plus 3 we have what 5. So when we count now, so let's go. 2 plus 8 we have 10, plus 5 we have 15. So the elements with this is what class? Phosphorus. Are you with me now? So now, I dropped a video on atomic structure and bonding yesterday. That video will help you here also. So this is because when we come to this kind of question already unpaired, we have what we call the neon core, we have the helium core, and we also have the argon core. All these are related to what we call the hybridization. I also drop a video on that also. But so this helium core is when you are having elements from helium, because we are talking about helium there, so exclude helium there, from beryllium down to fluorine. We always have a what? Helium core. But the moment you cross the neon, that's the element 10, then you're having neon core. So we'll be starting from sodium, magnesium, aluminium. Those we carry what we call the what? The neon core. Don't forget I said elements from beryllium down to fluorine will carry what? Helium. While elements from sodium down to chlorine have what? Neon core. So guys, this, so with this now, so let me write this. You can see we have 1s2. So 2 plus 2 is what? 4, plus 6 10. So you can see that we are having 2 plus 3 here to give us 5. So meaning that we have crossed that lane of neon core. So you can say this, we are having what? Neon core. And the next one here is what? S. And don't forget yesterday when I dropped a video on the atomic structure and bonding, I show you guys the degenerate orbital for s orbital, p orbital, d orbital and f orbital. So now this for our p. So now, and from the question we want to look at how many unpaired electrons are there in the element. This is how you can easily get your answer if you are looking for unpaired electron. So what do we have here, class? We have 2, said 1 electron, the second one. Are you with me? And here what do you have here for p? If as a JAMBite you are feeling the degenerate orbital like this, It means you did not understand the concept of Ohm's rule that states that electron must be singly filled equally before pairing occur. So now, pairing cannot occur here because it did not singly fill it. So the correct one is, we have to claim this. We are having 3. So singly fill the 3. You can see now. Now, the question is, how many electrons does this degenerate orbital, which is p orbital, please take note of that, for 3p, and here we have 3s. So how many electrons does this p orbital of 3p needs to attain its stability? You know, we talk about, before I start the video, I say for every unpaired electron, they need a certain number of electrons to attain their stability. So here now, how many electrons do we need here to attain the stability, in the sense that don't forget that our p orbital has 6 electrons for the p degenerate orbital. So now, but we are having 3 here. So meaning you can say 3, 6 of the p orbital minus 3, which is this 3 here. We are having what here? 3. Meaning that we have to singly fill another 3 here to make it 6 electrons there. So go back to this place now. Our answer, our option here, we have 5. Here we have 4. Here we have 3, and here we have what? 2. So it tells us that what 3 is the answer, because you can see we needed just 3 more electrons here to make this p orbital here to attain its stability. Is that clear now? So now the last one states the electronic configuration of X. The atomic number here is what? 22, and we're having the charge to be what? 2 plus. First and foremost, if you have to tackle a question like this, elements with atomic number 22, those are the elements in the first transition rule, and the first one, which is 21, is scandium. The one with atomic number 22 is what? Titanium. And first, write out the electronic configuration first before you can look at the charge. So we can go, we said 1s2, 2s2, 2p6, 3s2, 3p6. According to the above principle, we have 1s, 2s, 2p, 3s, 3p, 3d, 4s, 4p, 4d, 4f. So this is the arrow. We'll move like this before we go back to what? 3d. So we can say we have 4s2 and 3d2. But in your JAMB, your 3d, they can place it before the what? 4s. What you just need is that you need to understand how to write the electronic configuration for the first row of the transition element. So now guys, this is for what? Titanium with atomic number what? 22. But now titanium is coming with positive charge 2, and we all know that in chemistry, if any element is having a positive sign, either +1, +2, +3, it shows that that element is losing an electron. So for it to have +2 here, it shows that titanium is losing 2 electrons. And this is a question: where is the 2 electron going to what? Occur? The loss of electron. Listen attentively to this. For every first row of transition elements, the loss of electrons from scandium, titanium, vanadium, the loss of electrons for all transition elements except 2, copper and chromium, their loss of electron always occur at 4s. Again, for the first row of transition elements except chromium and copper, others lose their electrons from 4s. Why is chromium and copper different? Because their 3d has a stability already, so it does not have any effect on it. So but others can lose their electron from 4s. So now, if that weight I just state clearly now shows that what, for every element like titanium that has 2 plus here, we lose its electron from what? 4s. So when you cancel this now, you can see we are left with what? 1s2, 2s2, 2p6, 3s2, 3p6, and 3d2. So guys, this is when an loss of electron occur. So guys, go back to these options now. I tell you guys earlier that we are not going to just show you guys why A. We are not picking answer A. We show you guys why A is A, B is B, C and D is what? The answer. So without me looking at the options, with what you have here, the answer is here already. This is what? Titanium. Correct for electronic configuration, but with charge it is not correct. What you have here is for scandium, and what you have here is for argon. Is that clear? 288, that's for argon, while the last one is for what? Titanium with loss of 2 electrons. So our answer is what? D. So guys, if you are still having misconceptions of, or you don't understand the concept of electronic configuration, check my video catalog. You just search electronic configuration. If you see how I explain it explicit. So guys, don't forget to subscribe to my channel, like and share among your colleagues.